about my work in developing a Windows-based automation Python tool to automate the UI software testing. As you can see, here is an image of our product. It is a very portable device which can scan different items. We have used it for orthopedic imaging, veterinary practices, and also non-destructive evaluations. And to bring our product into the market, there are two barriers in order to satisfy the regulatory agency, the verification and the validation process. Today, I'd like to emphasize on how I use automation to drive the developments of automating in the verification processes. In the medical imaging industry, we really want to ensure that patient safety stays as an utmost important aspect. And so testing is very important in order to release a good product. And before I start talking about automate testing, let me introduce you to my company's product. So we are a company that develop a destructive medical imaging technology, which is a X-ray device that shines X-ray from multiple angles, and these images get reconstructed together using a complex mathematical algorithm and creates 3D high-resolution images. Compared to CT, it offers low-dose technology, and it offers a much better image resolution compared to the 2D radiography images. As you can see in here, I have a 2D radiography images where all the different tissues are all blurred together, but with our technology, there is much more distinctions with the bones and the tissues. Here are more illustrations of the cadaver images that we collected in the hospital. So you can see that we have created these very good depth resolution images of all the bone structures and in orthopedic applications. We not only have applied our technology in the orthopedic industry, but also in veterinary practices. So today, since I'm talking about Python-based testing, I also included pictures of a snake. And you can see that with our imaging technology, we can see the bone structures and also the things that the snake has consumed in its body. We have also used it to scan exotic animals. And more recently, since it's Easter, we have a very interesting story from a vet practice where our technology has helped a turtle, which has a lot of eggs that traps inside its body, to restore it to full health by extracting all the eggs that were trapped. And according to the vet clinics, it was a job excellently done. Dental images is also a very big problem in the veterinary practices. A lot of times the tooth are retained inside, and it cannot be clearly identified with the 2D radiography images. But with our technology, we can clearly see the retained roots. Here is a pictures of the cat dental images, and here is the pictures of the dog, and then here is the pictures of the rabbits. So now I'm going to talk about how I use automated testings in my work as a software test engineer at my company. We have already deployed the CI/CD pipeline where the software gets released very periodically, and to manually test each of the released software, it would be literally impossible. So we want to come up with a way to continuously test. and to report to find out defects as early in the pipeline as possible. So I've developed a way to automate the test, create a test evidence, and then reporting it in a HTML test report. In the industry, as we all know, the testing pyramids, a lot of the tests are all done in the low-level tests in the unit test. And the UI test is hard to automate. And so today, I would like to just share with you the way I approach the problem to automate UI tests to create more scalable and fast UI system end-to-end tests. There are a lot of things that I can do with these automated tests, and I would like to find out, to prioritize the tests that are mostly important to me, and to develop these more important tests first, and then focus on the other tests. So the first and most important tests are the patient safety related tests, or the patient information test. So if these things are done wrong, then the product could be retracted from that market, and it could cause the company great loss. The other type of tests that I consider that are good to automate are the low-hanging fruits. These are the usability tests features of the UI, which includes filling out the forms, selecting buttons, and putting in different boundary values into the text boxes. And the third level of tests that I found, which would be interesting to automate, are the performance monitoring. We can, unlike the manual test, which is going to be impossible to test over thousands of times, if we use automation technology, we can monitor the CPU and memory usage of the UI software over time, and to evaluate if it gets overused. So now I'm going to show you some of the demos of these automated tests that I've created. So this first test that I'm going to show includes a 2D image acquisitions, and then a 3D image acquisitions, and then it's going to slide through the images to see the different numbers that are in focus. So in here, I have not clicked on any buttons. It's all done through automations. And as you can see, the patient demographic gets selected, and the image acquisition protocol are selected. And then it gets into this 2D acquisition mode. And then the image gets acquired. And the next thing that's going to happen is the 3D acquisition. In here, we use a Raspberry Pi to emulate the continuous activation switch, which will take the signal 0 or 1 to emulate the behaviors of pressing or releasing the continuous activation switch. And now the image gets reconstructed, and I'm just going to fast forward it a little bit to show you the image slicing. So you'll see in here that there are different numbers that were showing in the slice, and these are the way that we evaluate our image resolution. So here you can see like these numbers in focus. The other type of patient safety-related test I felt would be good to automate are the DICOM tag comparison. The DICOM is the type of medical imaging image type, and similar to JPEG or PNG, but for medical images. And alongside with the medical image itself, it also carries along with the patient demographic information as well as image acquisition protocols. And if these information are not not taken correctly, it can cause great problems. So we wanted to make sure that these can be done correctly. And through manual testing, it is really difficult to compare it individually. But with automations, it's much easier to be done in a fast and large scale. The second type of test, which I previously mentioned as the low-hanging fruits, are the usability type of test. These are inputting the text or entering different values for the boundary value analysis. And I'm going to share with you a demo of how to enter different combinations of text into the UI software and to make sure that the text inputs are validated correctly. So as you can see, I can enter in many different types of text in there and to create different scenarios of edge cases. And these processes can also be recorded using screenshots or screencast using Python to record these as test evidence. And here I have entered some text which is forbidden. And as you can see, that the UI have validated correctly and forbidden these invalid texts to be entered. And these gets cleared out, and I will also enter some empty spaces into the text box. And as you can see, the UI will successfully remove the empty spaces. And then here is an example to show you how to change the different drop-down selections to other image acquisition protocols. And here it deselected the auto default options and changed the values to different ones. And in this demo, I'm going to share with you how the image is selected with the different boundary values. So in these scenarios, you can input the different numerical values for the text box selections and to see that if these get validated or not. And here, it will go to the slice spacing and change the values for the slice. So this will allow you to perform boundary value analysis. The third type of test that I like to automate is the performance monitoring, which is to monitor the CPU and the memory usage of the different components of the device being used over time. And in theory, these will create a graph, and you will see how the CPU and memory usage goes over time during each iterations. So the magic behind all these automated testings is called PyWin Auto. So it is a Windows-based Python library that I consider as the missing piece in all the puzzles that I'm trying to solve. So the Selenium is mostly for the web-based development, and then if we have combined the PyWin Auto, we can essentially create a really powerful test to not only test the web aspects of the software, but also the Windows-based software in conjunctions. In test automation, there are a lot of good practices, which includes modularized design, solid principles, and automated reporting, and creating multiple layers. So I wanted to create that in my test framework. I also have created charts for the similarity and contrast between the two tools. So I just wanted to emphasize about the PyWin Auto. It is a much smaller community software where there isn't a large community base as Selenians right now. And it has limited documentation, but it does the very niche things that I like for the window-based UI automation. So I think it satisfies my users' needs very well. And now I'd like to go through the tutorials for my talk. In this tutorial, I'd like to share with you how I click on the UI buttons, set up the predefined variables in the project, and the custom variables, and how I would select a drop-down menu or use the Internet of Things with the test script. I also like to discuss how I can record test evidence, such as taking a screenshots, taking a screencast, or log an event or an error. I'm also going to share with you how I would test the imaging tool features in the UI software, how to extract performance data of the applications, and how to read the DICOM image metadata and do comparison. Lastly, my company uses a requirement traceability software called JAMA, which provides an API. And I would also wanted to share how I uses this API to create a HTML test report to include the test description, the test procedures, as well as all the test evidence that I've collected. So first of all, I've created some functions for clicking on the UI buttons. And I can create a exception class to record the exceptions. And I can also use as fixtures to wait till the buttons gets activated and then click on them. Or I can do a more simpler versions like the click buttons function, where I can find the elements by the title or the auto ID and to select on them. And this kind of finding of the auto ID or the accessibility features can be found using a tool called UI Spy. And there are other similar tools that can help you find these UI elements. And also, to create these accessibility tools, I collaborated closely with the the software developers to create these accessibility IDs. And then I don't want to set up the test environment every single time. So to simplify my workflow, I would create these predefined variables before I get into the test. And this can be done using the PyTest framework called parser and requests. And so in each of the tests, my software path gets selected without too much setup. Similarly, I can also set up the log levels and the wait time durations between the different processes. I can so in my test, I can either use a emulated UI or use it with a real device to test the different features. And so that's why there are the mock or not, which is set up. And then to select an items of the drop-down menu, I can first select the items with the auto ID, which equals size, and then I will give it some durations to wait till the next process is available, and then to select the exact type of size that I'd like. And as I previously mentioned, during the X-ray emissions, I need the regulatory agency requires the use of a continuous activation switch. And here is a picture to show you how it looks like. And it will be literally impossible to use the automated test and press it every single time when the test scripts run in tandem. So we use a Raspberry Pi that will simulate the pressing and releasing of the switch. And this will help us with the automated testing. And here is the script that I used to set up how to press and release the continuous activation switch. So first of all, I needed to find out the port for the Raspberry Pi, and then I'll send the signal, which is already programmed in the Raspberry Pi, to either press or release, turn on or turn off the switch. And similarly, to release it, I would just send the signal to release the switch. And the setup and teardown structure fixture is also really useful in my testing framework. So I have set up something where I open the app, and then I close the app, and then I use the fixture to put them all together to automate these processes. And in my test, I use some of the hotkeys to close things. As you can see, in the close app, there is a %F4, which will close the applications. And then sometimes there are a warning pop up that asks me if I really wanted to unsave the acquired images, and I will click on the confirm button. And then to create the test evidence, I will take the screenshots, and to do so, I will use the really useful library PyAuto GUI. And first, I will select the path to save the images, and then I'll take the screenshots. And then similarly, I can also take a screencast of the testing procedure using the multiprocessing library. The first functions I've created is to take the screenshots, and then I'll create another process, which is the functions or the automated testing procedures. And then I'll join these together. So essentially, the end result is the screen recording of the process that I scripted in the try block. And then to set up the logs, I've also created a fixture here, which will help me log any issues or problems. The next thing I'd like to discuss is the imaging tools. So here I have screenshots to show you what it looks like. So the orange line is a ruler, and the L is a laterality marker to show you the left or right of the images to mark up the medical images. And To emulate these functions, I have a lot of different ways to do the user manipulations. So for example, if I wanted to drag the laterality from one position to the other, I can use I can first select the positions of the laterality marker and use the mouse function to drag it to a different location. I can also simulate the pan functionality by finding out the positions of the image viewer and then to drag it to different directions as I wish. And similarly, I can put rulers using these combinations of tools. And I can also scroll up or down. So the image viewer, when you use the up and down key, you can scroll the slices up or down to see the different depth images, or you can zoom in and out by clicking on the left or right key. And so I can use the hotkey to emulate these users' behaviors. And then to rotate, flip vertically or horizontally, I can just click on the buttons. And then to change the contrast of the images, I would just click on the image and then drag it to a different directions. And these imaging tools can be tested in such a way. Lastly, I'd like to talk about how to extract the performance data of the applications. So this can be done by using in conjunction with the PSUtil, which is the PowerShell utility library. And I can have a pandas that record the different performance data and then record them in real time and then record it into a CSV file and then later on plot it in a graph. And then to read the DICOM image metadata, I can use a library called PyDICOM and then extract the different values of the DICOM metadata. And so the idea is that I have input a lot of the expected values, and I can compare it against the actual output that gets generated in the images. And then I also like to share with you the HTML reporting of the text execution. So here is a quick slide to show you what it will ultimately look like. In the left of the slice, you can see that the test ID of the test and the name of the test, and then it follows with the descriptions and the test procedures. And then after that, it will also include the screenshots, the tables, as well as the logs that were created after the automated tests. So this is achieved by using the JAMA API. And first of all, I will connect to the API tool, and then to find out the test ID, and then search for the description, the test case steps, and then to return these values. And then I would also wanted to convert the CSV, which is the DICOM tag comparison tables, into the HTML elements, or the logs text text into the HTML elements, and then putting them together, I'll aggregate it into a HTML report. So this helps me to read my test more easily, unlike going to a folder and finding out what the image looks like. So in conclusions, I have found out a way to test the window-based software. And this tool allows me to test things in scales and speed up the testing process. There are still some limitations with the test tools, as I mentioned, that this is a very niche testing Python library. And I believe that it will allows us to scale up our test and to test with more impact and possibilities. And lastly, I'd like to thank my colleagues at Adaptix, especially David Woods, Andy Wilson, and Miguel Carls for their support in my work. And if you have any questions, please feel free to share, or you can direct these questions to my email. Thank you very much.
Hello.
Hello.
I just would like to clarify regarding the image recognition. And I saw that you take the screenshots and after that put them in the HTML report. But do you have some automatically approach how to compare these pictures, or it's like manual only during this HTML report after the test execution?
Thank you very much. There are certain tests that requires testing whether the logos is in the tests, is in the UI elements, and I've tried to use image recognition to do the comparison, but it seems like with a very small variations of the UI development changes, these comparison fail the test. So I just felt like if I just manually evaluate the test after everything is compiled, it would be a much more effective way than to automate the image comparison. And actually, the first iterations of my automated tool was done with a PyAuto GUI to do the image recognitions of the buttons. But it seems like this is a less effective way than to use the accessibility features of the UI. So that's the kind of step up or progressions for how I improve my testing frameworks.
Okay, and regarding these pictures of the X-rays images, do you have any like image test for it, or it's again like manual part only?
Thank you. That's also a really great question. So the image currently is in a different type of format that cannot be converted to a to a numerical value images, but I think it would be a great improvement in helping me to evaluate what the image quality is, which is the essence of what our product is. And I think that would be a great next step for me to do in the future.
Thank you so much.
Thank you.
Hi, and thank you for the presentation. What were the biggest challenges you faced when you did that?
So the biggest challenges would be to when there are newer software release, there can be small changes, and I have to change my testing procedures to meet the updated software. So I find that sometimes with the maintenance of the testing tool, it becomes a bit difficult. But I think by improving the testing framework, it can become a long-term automated solutions. And I also think that sometimes with the lifetime test, which is the stress testing of the UI test, it can sometimes break along the side, and sometimes it is really hard to find out what the problems are, and you just have to wait for those errors to be reproduced again. Thank you. Thank you very much, everyone.